Buford 7th graders. This is Unit 4, Lesson 2. Brought to you by me. My name is Tom.
No!
Oh, yeah.
No!
The theme of this unit is called Did You Know? I'm going to be telling you a bunch of cool facts. Really about everything. So, pull up a chair. Get your guided notes. Don't you fall asleep.
No.
You hear me talking to you? Don't you fall asleep.
No.
And get ready. You guys are awesome. So let's listen, some good notes, and do this thing. Here we go.
No!
Here we go. Unit 4, Lesson 2.
No!
Hello Buford Middle School students, this is Mrs. Brigman, and today we are going to begin Lesson 2, part of Unit 4, Inferences. Our essential question for today is, how can I describe the center of a set of data, what conclusions can be drawn from that data, and how can I use data to compare different groups? Before we get started today with Lesson 2, please find your guided notes, make sure you have a pencil and a quiet place to work. Remember, you are to fill in the blanks on your vocabulary words, and any examples that you see me work out on the screen, you need to be writing those down in your notes, paying full attention and trying your best to understand the steps for solving each problem. All right, let's get started and jumped ahead here. We have several vocabulary words for you guys. You will definitely need to press pause and fill in your blanks. I will talk to you about these words as you're filling them in. Your first 3 words should be a review, and these are our measures of central tendency. That is mean, median, and mode. Starting with the mean is simply the average, if you would fill in your blank, average, or fair share value for the data. The mean is also the balance point of the corresponding data distribution. So by mean, we mean the average of a set of data. The median is the second type of measure of central tendency. The median is like the middle number in your set of data. So as you're filling in your vocabulary words, you should say, fill in the value for which half the numbers are larger and half are smaller. If there are 2 middle numbers, the median is the arithmetic mean of the 2 middle numbers. And just a side note, the median is a good choice to represent the center of distribution when the distribution is skewed or outliers are present, and we'll discuss outliers and what those are shortly. Your third measure of center is mode, and mode means the number that occurs the most often in a list. So if you can remember mode is the most, then you will be good to go. There can be more than one mode, or there could possibly be no mode. Now, this lesson mainly focuses on these three, and these are called measures of central tendency, because these are basically just values that attempt to describe a central position within a set of data. So that's why they're called measures of center. And we are going to in today's lesson, mainly discuss how to calculate each one of these. And also we're going to talk about, under different conditions, how some measures of center may be more appropriate to use than others. So again, we'll learn how to calculate these, and then we'll talk about under what conditions each one would be more appropriate to use. So that will be our main focus of our lesson. Our last three vocabulary words have to do with variability, and by variability I mean how a data set is spread out. Your first vocabulary word is measures of spread, and this is simply the range and the mean absolute deviation, and these are both common ways to measure the spread for a data set. Your next word is mean absolute deviation, and this is the average distance of each data value from the mean, and we will discuss this one later on, not in this lesson, but later on. One important thing I want to tell you about mean absolute deviation, it does have an abbreviation, and that would be capital M, capital A, capital D, MAD, mean absolute deviation. Your last vocabulary word is outlier, and this is a value that is very far away from most of the values in a data set. If a data set includes an outlier, then the mean of the data is skewed. If you need to press pause to fill in the rest of your blanks, please do so at this time. All right, here's a little comic of an outlier, just a little play on words. The little student is saying outlier, and she is talking to this little point on the scatter plot that says your theory is wrong. This is technically the outlier because it is a point that is much farther away from the rest of the points in the data set. So let's talk a little bit about an outlier before we move on. This is just a cute little comic, but a real outlier is basically just a value that is much greater than or much less than the rest of the numbers in a data set. So, for example, let's say that I am looking at some quizzes that my students have completed, and these are the grades. A student received a 91, another student received a 85, a third student received a 95, a fourth student received a 35, a fifth student received an 80, and a sixth student received a 93. This is considered my data set because it represents all my different students and their quizzes. Now, I can do a lot of things with this data set, but one thing that I want to point out is the outlier. The outlier is the number that is either much greater than or much less than the rest of the numbers in the data set. So can you pick it out? Which number do you think is much greater than or much less than the rest of the numbers? If you picked 35, you are correct. 35 is the outlier because it is much less than the other numbers in my data set. And we'll talk a lot about outliers today and how they can skew your mean, your average. If I were getting a class average of this data set, that 35 would bring my class average down. So that is why we say outliers affect the mean. Alright guys, we are going to do a few examples today looking at mean, median, and mode. So let's start with example 1. This example says, in Miss Lynn's 7th grade class there are 21 people including Miss Lynn. Their ages are, and they are given. It says find the mean, median, and mode, and then our second question is Analyze the data. Which measures of central tendency would be the most appropriate to use? So let's go ahead and get started. First, we're going to find the mean. And the mean is simply the average of the numbers. So to find the mean, you are going to add all of the numbers in the data set, which I have already added them. And the sum is 273. I added each and every one of these numbers to get a sum of 273. Then I'm going to divide by however many numbers are in the data set. There are 21 total people in the class, and that's how many numbers I see here, 21. So I am going to divide by 21. 273 divided by 21 equals 13. So my mean, or my average age of students in this class is 13. All right, I'll choose a different color to find the median. The median is your middle number in a data set. So the steps, first you need to place all of your numbers in the data set in order from least to greatest. From least to greatest. And I am lucky because in this example, the numbers are already listed from least to greatest. So that is very important. When finding the median, first list your numbers in numerical order from least to greatest. Your second step would be to cross out the numbers until you reach the middle. So I'm just going to start with the first one, and I'm going to cross out front, back, 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 front, back. And you can see that the middle number is 12. I have exactly 10 numbers to the left of my middle number and exactly 10 numbers to the right. So this number 12 is exactly in the middle of my data set. All right, the last measure of central tendency that we need to find is the mode. Mode means most, which value occurs the most, and I can figure that out by counting each value, and it's easy to tell that the number 12 occurs the most. These are my measures of central tendency. Remember, measures of central tendency, mean, median, and mode, aim to just describe the central point of all the data. So these numbers describe all of the 21 numbers in my data set. Now let's look at number 2. It says analyze the data. Which measure of central tendency would be the most appropriate to use? So let's talk about that. Let's look at the mean. The mean is 13, and the age 13, if you look in your data set, is not even seen here. So 13 really wouldn't be a good age to describe this class. The reason that the mean is 13 is because you do have an outlier of 37. The teacher's age is much greater than all the students in her class, and that 37 bumped the mean, bumped the average up. So that's the reason it is 13. So the mean would not be a good measure to use. Moving on to the median and the mode. The median might not be the best to use simply because using the middle numbers doesn't always account for all the kids in the class. The mode would be the best one to use because you are referring to the age of the kids in the class, and that would be what occurs the most frequently. The most students have an age of 12, so 12 would be the best representation. So this answer is mode. Mode is the best measure of central tendency. All right, example 2. This example looks at a frequency table. Let's read the directions together. It says, the table below represents the number of goals players on a soccer team scored in a season. And you can see the score and the frequency. Now, generally frequency tables we'll have a tally row, and the tally, each tally mark represents how many students scored 10 goals. So for this first one, we had 5 students that scored 10 goals. And this part is not in your notes, but generally you will see frequency tables with a tally column as well. It looks like 8 students or 8 players scored 9 goals. 10 students scored 8 goals, and then 2 students scored 7 goals during the soccer season. So this would generally be how you see your frequency table. All right, the question says find the mean, median, and mode of the data. So let's go ahead and get started. First, we'll find the mean, and the mean is the average. So you are going to add up all the numbers in your data set and then divide by however many numbers there are. Now, don't be fooled by the way that the frequency chart is set up. Let's talk about our data. We are looking at the number of goals that players on a soccer team scored in a season. So this first row means that 5 players scored 10 goals. So if I were going to write this out, I would write the number 10 5 times. Now, I'm going to go ahead and write out my data set, and I know I'm going to eventually have to find the median. So I'm going to go ahead and put my numbers in order from least to greatest. So I'm going to start down here. The score was 7, and there were 2 players that scored 7 goals during the season. So I'm going to write 7 twice to represent those 2 players. There are 10 players that scored 8 goals, so I'm going to write 8 10 times. So go ahead and do that in the space below. All right, we have 8 players that scored 9 goals. So I'm going to write the number 9 8 times. And then finally, we have 5 players that scored 10 goals. So we are going to write the number 10 5 times. So just to clarify, this was the number of goals that the player scored each year, and this is the frequency. And frequency just means how often something occurs. So 5 players scored 10 goals, 8 players scored 9 goals, 10 players scored 8 goals, and 2 players scored 7 goals. So that's how I got my data set. All right, so when finding the mean, I'm going to add these numbers together. 7 plus 7 plus 8 plus 8 plus 8 plus 8 plus 8, etc. So when you add those numbers up, you are going to get 216. That is the sum. We're going to take 216 and we are going to divide by however many numbers there are, which there are 25 numbers in this data set. 216 divided by 25 equals 8.64. So the average or the mean number of goals scored by players during the soccer season is 8.64. Now let's find the median. Since I went ahead and wrote out all my numbers in numerical order from least to greatest, I can just start by crossing out front, back until I get to the middle. So I'm going to go ahead and do that. Okay, and 9 is the middle number. So 9 goals is my median. And then finally, we're going to find the mode. Mode is the number that occurs the most. You can look at your list or you can look at your frequency column and you can easily see that the 8 goals was scored the most because 10 players scored 8 goals. So the number 8 occurs the most. So these are my measures of center. And by measures of center, I mean these are the numbers that attempt to describe the central position of all of the data in the frequency chart.
Oh, good grief. Okay, it's time for a break. So stand up, stretch a little bit, do a little dance.
No!
Oh yeah. And here are some facts for you. Did you know?
Let's move on to example 3. It says Zach wants to have a mean score of 80 on his health quizzes. He scored 70, 75, 82, and 90 on his first 4 quizzes. What score must he earn on his 5th quiz to have a mean score of exactly 80 for all 5 quizzes? Now, I want you guys to pay close attention to this when you are going to see several questions during this unit that look just like this one, where you have to find what does he have to score on that 5th test to have an average of 80. So let me show you the best way to solve this. If you would put a little star and write an algebraic equation, that will remind you what to do. You know from the question that you are working with a mean score of 80, and we know that the formula for mean, how to calculate the mean, is to add up all the numbers in the data set and divide by however many numbers there are. So that is exactly what we are going to do. The mean, he wants to have a mean of 80, so we want our algebraic equation to equal 80. If we were going to calculate the mean, we would add up all his quizzes. So on his first quiz, he got a 70. On his second quiz, he got a 75. On his third quiz, an 82. On his fourth quiz, a 90. And we are trying to find, what does he have to get on this 5th quiz? The X represents the 5th quiz to have an average of 80. So what we would normally do is add up all the quizzes, quiz 1, 2, 3, 4, and 5, and then we would divide by however many numbers there are, however many quizzes he had, which there are 5. 1, 2, 3, 4, 5. This is your algebraic equation that you want to set up. Now you simply solve for x using all of the rules about equations that you know. Starting with the numerator, we can combine like terms. We can combine our constants. We can combine a 70 plus 75 plus 82 plus 90 for a total of 317. We will add on our plus x divided by 5 equals 80. Our next step would be to start on the side with the variable, and we will use inverse balance solve to solve for the variable. First, start with the number farthest away from the variable, which is 5. They are dividing by 5. So we are going to multiply both sides by 5. And then we'll solve. This cancels. 80 times 5 is 400. 317 plus x will simply come down. And then your last step will be to subtract 317. So we'll subtract 317 over here. And you can see that the answer is 83. X equals 83. Zach needs to score an 83 on this 5th quiz in order to get an 80 on an 80 for an average. Now, these questions you can always go back and check your work. Simply plug in the 83 where the X is. So I would calculate by adding all of these numbers, dividing by 5, and I do indeed get 80. So I know that this is the correct answer. All right, example 4. This is a stem and leaf plot. A stem and leaf is where your number that's in the tens place value is your stem, and then your ones place value is your leaf. We are going to use this stem and leaf plot to calculate the measures of center for Jamal. Let's look over here, and it says this week Jamal was ill, so he only biked 11 miles. How does this change the median and mean of the data? And here you can see this is the miles that he biked for the past 10 weeks. So this is the 10 weeks, and then the 11th week he only biked 11 miles because he was ill. And we're going to talk about how does this change the median and the mean of the data. So let's start by looking at our stem and leaf plot, because this has our data for Jamal. And I'm going to write his data right here. His numbers, his first week, he rode 36 miles. And I'm getting 36 from the stem and the leaf. The next number is also 36. So the second week, he also rode 36 miles. Next, we have 40, 43. We have another 43. 45, 47, 48, 49, and finally 53. And that should be 10 numbers. That's 10 weeks. Okay, we're going to start by calculating the mean, and we are going to find the mean of the 10 weeks, and then we are going to find the mean of the 11 weeks, and we are going to compare them. So starting with the mean of the 10 weeks, I would simply add up these numbers, which it equals 440, and divide by 10 because that's how many numbers there are in my data set. And the mean is 44 miles. This is the mean of the 10-week data. Now, in a separate color, I'm going to find the mean of the 11-week data. So it says this week Jamal was ill, so he only biked 11 miles. So technically, I'd be adding an 11 down here to my data set. And we're going to go ahead and calculate the mean. If I add an 11 to the 440, that equals 451. But this time I'm going to divide by 11 because there are 11 numbers now in my data set. And 451 divided by 11 equals 41 miles. So you can see that for the 10 weeks he biked an average of 44 miles. And the mean of the 11 weeks was 41 miles. So that's a difference of 3 miles. The week that he was ill, he only biked 11. This is called an outlier because it is much smaller than the rest of the numbers in the data set. And the reason he only biked 11 was because he was sick. So how did that affect the mean? Well, it dropped the average. So notice that outliers, they are going to really affect your mean. If it's a number that's much smaller than the rest of the numbers in the data set, it is going to bring that average down, which is just the case here. Now, in addition, this question has asked us to compare the median as well. So what I'm going to do, I'm just going to erase my mean work here, and then we're going to work on finding finding the median. So first let's find the median or the middle number of the 10-week data. So ignoring this 11, in fact I'll just erase it here. All right, let's find the median of the 10-week data, and we'll do that by going front, back, because our numbers are already in order, so we can just start crossing out front, back, front, back, front, back, front, back. Now, what happens when you have two numbers and you need to find that middle number in between those two numbers? You have to find the average of these two numbers. And the way you would do that is you would add 43 and 45. You would add these two numbers together, which in this case you get 88, and then you would divide by 2 because we have two numbers that we're working with. So the median of these two numbers is 44. So the median for the 10-week data is 44 miles. All right, now let's find the median of the 11-week data. So just the same, I am going to erase and rewrite my data with the 11 included. So 11, and then I'll rewrite the rest of the 10 weeks. 36, 36, 40, 43, 43, 45, 47, 48, 49, 53. 11. I always go back and recount my numbers just to make sure I counted for every single number. And then again, we're going to cross out front, back, front, back, front, back, front, back, front, back. And this time we actually do land on exactly middle number, which is 43. So let's take a look at our median. Our median only lowered by 1 mile. So if you think back to the last example, and I'll use yellow this time, it says how does this change the median and the mean of the data? The answer is here. The mean was lowered by 3 miles. The median only lowered by 1 mile. So adding that 11, that week that he was sick, adding that 11, it really affected the mean. It lowered it 3 miles, but the median, it only lowered it by 1 mile. So the main point of this problem, you are comparing measures of central tendency, mean and median, and the main point is that outliers, which is the 11 because it's a number that's much smaller than the rest of the numbers in the data set, the point is this outlier affects the mean the most. So when given a data set and you are given an outlier, you usually don't want to use the mean as your measure of central tendency because it will either pull your data down or it will pull your information up if it's much greater than. So again, if you are given an outlier, you usually do not want to use the mean for your measure of central tendency. You would usually want to go with the median or the mode. All right, guys, our last example that we are going to cover in this lesson is example 5. It says, which would be the best measure for each situation? Number 1 says, would you use mean, median, or mode to describe the typical selling price of a bicycle? And sorry about that. So looking at this, which measure of center, mean, median, or mode, would best describe the typical selling price of a bicycle? I want you to notice the word typical. The word typical means average. So typically, what would be the selling price of a bicycle in this particular store? Would you want to use the mean, median, or mode? And so the answer would be the mean. You would want to go with the average selling price. And then number 2 says, would you use mean, median, or mode to determine the most popular toy? And most popular would be your hint word here. Most popular means most. So to find the most popular toy, you would want to use the mode. So sometimes you're going to be given situations and you just need to look for hint words such as typical or most popular to identify whether you should use the mean, which is the average of a set of numbers, the mode, which is the number that occurs the most in a data set, or possibly the median, which is the middle number in a data set. All right, guys, that concludes lesson 2 on measures of central tendency. In your notes, you do have an example 6 where we are going to discuss the mean absolute deviation, and the abbreviation is MAD, the MAD. Your teacher will review this topic with you in class, and we will go over the examples of MAD as well in class. So what I would like for you to do is skip example 6, just leave it blank, and you need to go straight to the your turn question on your notes that looks like this slide. The question says, Owen took a random sample of 10 students who take piano lessons at a music school and recorded their ages. The director of the school took a census of all 30 students who take piano lessons at the school and recorded their ages. Owen's sample data and the director's census data are shown below. So you see Owen's sample data there and you see the director's census data. We would like for you to find and compare the mean, median, mode, and range of the sample and the census. You need to find the mean, median, mode, and range of Owen's sample and the director's census. Please calculate this on a separate sheet of paper. Do not try to squeeze it in that small space that is left there for you. You need to calculate this on a piece of notebook paper so that you can have plenty of space to work. You will complete this question and then you will complete number 2. Number 2 says the manager of an online bookstore kept track of the number of books in each box that was shipped for 100 orders. His assistant randomly selected 2 samples from his data and calculated the mean and median for each. And you see sample A and sample B. The question is, which sample is more likely to have a mean and median that are good approximations of the actual mean, which is 12.5, and the actual median, which is 11.5 of the population. So what you will need to do is calculate the mean and median of each sample to see if your guess was correct. Please complete the your turn questions 1 and 2, and then you may stop there. You do not have to do example 6 or your turn questions 3 or 4. You only have to do your turn questions 1 and 2. We will discuss these tomorrow in class. Hope you have a good evening.